Excellent. Okay, by the end of this segment, we'll hopefully have installed a large screen cycle analyst on your Vectrix conversion. I'm going to skip through the part where we're dismantling the bike, because if you're doing it during the conversion, it will already be dismantled for you, and I've covered it in earlier videos. So if you need to know how, look at the earlier videos. We'll start off by taking off all the covers, so then you have something like this. First thing you do is unplug the Andersons. That way, so that when you're wiring it up here, these two terminals don't have 150 volts across them. When those Andersons are apart, there's 0 volts across them. So if you drop a spanner, the worst thing that happens is you short out a couple of cells, and they're much easier to deal with than short out the entire battery. Believe me, I know. On this particular conversion, I dropped a spanner once some time ago and melted one of the bolts. It actually stayed tight, so I didn't actually take it out of circuit at all. But that's one of the consequences of shorting stuff out. Alright, what will need to happen is you need to take off these two bolts on the negative side. On some conversions the negative will be in this side. It doesn't really matter, it just has to be the negative side. Because what's going to happen is I'm going to put a shunt, which is just a calibrated resistor, underneath, and they tend to be a little bit taller than the interconnect on this side. So we're going to have to use longer bolts. Recommended shunt size for the psychoanalyst is 100 amps, 75 millivolts. That gives you the best, allows you to show the full range of current the Vectrix draws, as well as give you maximum resolution. Stop video, please. Okie dokie. I'm using two of the Thunder Sky interconnects, and EV works. Braided interconnect will work just fine. You only need one of the 60mm, the 6mm hole ones. Length doesn't matter so much, so you can use either the 50mm long one or the 60mm long one. Either is fine. I'll go with this. What we're doing is I'm using a 16mm M6 bolt with just a normal spring washer and a washer. So I'm slipping the interconnect underneath the BMS module, because we've done the bolts on both sides, and just slipping it on. Only tightening that down a couple of turns. Now, on the other side you have to use a 16mm bolt as well. However, it will need to be chopped up a bit so that the thickness of this interconnect is the same as the two interconnects on this side. It really depends on whether you use the EVWorks braided interconnect or two of these. So what we do is I use a spring washer on top, and then I put the washer underneath between the interconnect and the cell module. In fact, in this case I'll actually use two. So there's bolt, spring washer, washer, and then another spring washer. Again, tighten it down just hand tight so it's a bit loose and stuff can move around still. Next up, I'll be mounting the shunt on this interconnect. If it'll let me. In fact, I think it's going to foul against me. Yeah, it is too. Stop video, please. To stop the shunt fouling against the positive cable, what we're going to do is bend the interconnects down. So what do, put a bolt through the holes first to make sure the holes stay true with each other, and just push down with hard as you can until it bends into position. Once you think you sort of got it right, try putting the shunt in. If it doesn't foul anymore, you pretty much got it right. If it does, push it down a bit more and you should be fine. Now I've got that pretty much right. What we're going to do is we're going to undo this bolt again. So we're going to take that out. That way we can tighten the bolt down on the between the shunt and the interconnect while it's out of circuit. we only had this bolted down earlier so we could get it all measured up right. Screw that back in so it doesn't go missing on us. Now on this one with the bolt we're going to use a spring washer, and you probably should use a washer as well. Stop video. Okay, so when you're tightening it down, basically you want bolt, spring washer, washer, 2 interconnects or the EVWorks braided interconnect, then the shunt, then another spring wash, or then sorry, another washer on the other side, and then you want your nut. You will need to use the 6mm bolts to go through, otherwise you won't fit through the interconnect holes. On your shunt the hole will likely be much larger, which is why we want the washers. You don't want the bolt coming through. And then basically you just use a wrench on both sides to tighten it up. Where are my wrenches? In my case I'm just using a socket and a wrench. Helps if you set it in the right direction. Tell you what, a ratchet wrench is makes life much easier, because then when you're tightening you don't have to keep taking it off to turn it over. Very handy piece of equipment. Alright, so now that you've got that nice and tight, hopefully the bolts on the other side should line up. It's not looking like they will, but a bit of brute force and ignorance will fix that. Yeah. Alright, then we're sliding it back underneath. Silly me's got it the wrong way around, so I'm going to have to undo that and redo it. We want the 2 screws on this side facing upwards, because that's where you're going to be screwing onto a bit later, so it needs to be looking like that. Let me fix that.
Stop video?
No, keep going. I decided a while ago that I'd leave my mistakes in.
Oh, right.
On the video, I wouldn't edit them out. So I watch lots of these do-it-yourself type videos, and it shows everyone getting it right perfectly the first time, and that's not really all that accurate to reality.
Not real life.
No. Sometimes you do just stuff up and have to redo stuff. There we go. That's all part of the game. At least if you see my mistakes, then you know, even guys who've done it for a fair bit make mistakes. You're not on your own when you stuff up a little bit doing your own conversion. Alrighty, should give that one more shot. Alright, slip that in underneath there. And normally I'd be very scared to do this because there's usually 150 volts across here, but because we've got the Andersons apart, don't have to worry so much. Slip that underneath. Might start to fail again. Bit of brute force and ignorance. Next trick's getting this bolt through the hole. Alright, so I managed to get it through the interconnects. Now see if I can get it down into the cell. Alright. Turning out to be a real mission. There we go. Once you got the threads mostly in, you can brute force it with a wrench. So bending these back shouldn't cause you any more dramas. Yeah, it's bent down a bit. Excellent. Now the next part is to tighten this down. tightening, and to tighten this side down. Now what you want to check for on this bolt is to make sure it comes up to relatively much the same height as the other sides, so that way you don't have a bend in the BMS module. It can take a little bit of inaccuracy, but we try to minimise it where possible. And I think that's pretty much right. Yeah, it's looking good. Alright, moving on. Now you recall from earlier videos in the conversion that on this particular bolt we happen to have a bit of wire from the temperature sensors and then another wire from the BMS master, which I've left floating around here somewhere. There, perfect. These two you can wire onto the shunt. Filming please.